In this video, we're going to look at instantaneous rates of change. In GCSE Maths, there's two different rates of change. There's instantaneous and average. I highly recommend you also watch the video on average rates of change in Corbettmaths as well. Now at GCSE level, we find the instantaneous rate of change by finding the gradient of a curve or line at that particular point or time. At A level, we use a topic called calculus, but at GCSE level, we'll just find the gradient of the curve or line at that point, and then that will be the instantaneous rate of change. So let's have a look at our first example. So this question says, find or estimate the rate of change of y whenever x is equal to 4. So we want to find the rate of change of y when x is equal to 4. So to do that, what we're going to do is we're going to go to the x-axis and go to 4, and we're going to go up to the curve, and we're going to look at this particular point here. Okay, so we're looking at that point. And what we're going to do is we're going to draw a tangent to the curve at that point. So we're going to do that. Now, obviously, with me being on a piece of computer software, it's probably a bit easier than you on the page, but it's sort of, whenever 2 or 3 people do this question, they're going to get probably slightly different answers. It is an approximation. Okay, the only way to do it exactly is by using calculus. Okay, so here we've got a tangent, and what we're going to do is we're going to work out the gradient of that tangent. Okay, so as you see, it's a tangent, a straight line that touches the curve and carries on. So now we've drawn the tangent, what we're going to do is we're going to choose 2 points on it, and then we're going to use rise over run, and that'll be the gradient of the tangent, and that will give us the instantaneous rate of change at that point whenever x equals 4. So here we're going to choose 1 point on the tangent, so that point there, and let's choose this point here. You could use any 2 points. I've chosen 2 which are quite nice coordinates, 3, -3, and 5, 5. I've chosen those just because they're the sort of nice coordinates to choose. And what I'm going to do is I'm now going to do a little right angle triangle, and then I'll do rise over run. So in terms of that line, well, the run, well, 3 to 5, that's 2. And then the rise, well, we're going from -3 all the way up to 5, so the rise is 8. And so the gradient is equal to, well, for this line here, the gradient, let's call it m is equal to rise over a run. Some people talk about changing y over changing x, same thing, and we get 8 divided by 2, and 8 divided by 2 gives us the gradient of that line is equal to 4. So the gradient of the tangent is equal to 4. That means that the gradient of that particular point is equal to 4. So that means that the rate of change of y at x equals 4 is 4. And that's it. So the rate of our estimate for the rate of change of y whenever x equals 4 is 4, because the gradient of the tangent at that point is 4. Let's have a look at our next example. So here we've got a velocity time graph of a particle over 12 seconds, and it says find an estimate of the particle's acceleration at time equals 6 seconds, or at 6 seconds. So the rate of change of velocity is the acceleration. Okay, so rate of change of velocity is acceleration. So we want to find the rate of change of this curve whenever time is equal to 6. So that's at that particular point there. So again, what we're going to do is we're going to draw a tangent. So let's draw a tangent. And again, there's no sort of exact science in drawing that tangent, well, unless you were to do that at level topic of calculus. In the exam, there will be sort of tolerance. You're allowed to, that it's fine. There'll be a range of particular values they'll take. So, don't worry too much about it as long as you've drawn a fairly decent tangent, and then you get the gradient of it. Okay, so there's a tangent. Now what we're going to do is we're going to choose 2 points in it, and we're going to do rise over run. So let's choose 2 coordinates that are quite sensible to choose. So I'm going to choose this one here, because that's 0, 5. That's quite a nice coordinate there. And actually that point's quite good there, okay, which should be 10, 16. Again, you could choose any 2 points. I've just chosen those because to me they were quite nice coordinates. So again, we're going to do our rise over run. So let's draw our right angle triangle. So there's our run going across and our rise going up. So our run, well, our run is from 0 to 10, so our run is 10. Our rise is from 5 to 16, so that's equal to 5 to 16, that's equal to 11. And so our gradient of this line, let's call m is equal to rise over run, and that will be our rise, 11 over 10. 11 divided by 10, 1.1. So that is our acceleration, 1.1. Now let's make sure we've got our right unit. So acceleration is equal to 1.1. Now we've got meters per second for the velocity, and then we are looking at time, so how that changes over time. That's going to be meters per second, or meters per second squared, like so. Okay, so we look at the units here, it's meters per second, and then we were dividing by time, so we're dividing by another second, so that are another units of seconds, so we're dividing by seconds squared, so it's meters per second, or meters per second squared. That's it. So it says find an estimate of the particle's acceleration with times equal to 6. So to recap, we've drawn a tangent at 6, we've got our gradient of it by doing rise over run. That's given us our value for the acceleration of 1.1 because it went from 5 to 16. That's a rise of 11 divided by run, which was 10. And then we've got our acceleration 1.1, and we just put the units on, meters per second squared. Okay, and our last example. The last example says, below is the depth of water in a container over 6 seconds. So you can see the container's got a certain amount of liquid in it, well, just over 12 centimeters at the very beginning, and it's leaking and it's losing water, and by 6 seconds it's empty. And we've been asked to estimate the rate of change of depth of the water at times equal to 2.5 seconds. So again, what we're going to draw is we're going to draw a tangent at 2.5 seconds. So we're going to go to our graph, 2.5 seconds will be here. So about 2.5 seconds there. That's where we want to find the gradient of the tangent at that point. We then get our ruler, we draw a nice tangent at that point. And again, do the best you can there. To me, I think that's an okay tangent there. And now what we're going to do is we're going to choose 2 coordinates, and we're going to do rise over run. Okay, so that's a tangent that I'm going to use. I'm going to choose 2 nice coordinates on that tangent. So let's have a look. I'm going to go for, now, are there any nice sensible choices? 0, 14 is quite a nice choice there. And I think that coordinate there of 5.5 across and 8 up. So that's our triangle. We're now going to, our 2 points we've chosen on our line. Now we're going to find the gradient by doing rise over run again. So obviously this is going to give us a negative gradient because the line's going downwards. So our run, well, that's what we're going to cross. That's from 0 to 5.5. So 5.5, and our rise, well, it's going down here, so it's going to be minus, and it goes from 14 to 8, so it's a -6. And so that means that our gradient of this line, let's call it m, is equal to rise over run, and that equals rise minus 6 divided by run, 5.5, and we'll just type that into our calculator and we'll get what the gradient is. So that gives minus 1.09 to 2 decimal places. And so our answer is minus 1.09. And let's get our units. We had our depth, which is centimeters, divided by our rise, which was centimeters, divided by our run, which was seconds. So centimeters per second. So the rate of change of the depth of the water is minus 1.09 centimeters per second at that particular time at 2.5 seconds.